It's MOURAD Sultan Ezouidi, the mathematics teacher. Okay, today we are going to learn a new method. Okay, this method is consisting of solving or finding out all the roots of any polynomial to the power, and without an error estimation or without using approximation method. Okay, here you are going to give you exact value. Okay, exact values of roots. Okay, that satisfy our equation. Okay, so let's start. I'll just share the screen. Okay, so that all the learner, students, professors, and everyone who wants to watch this lecture, it's very important. Okay, I will share this. Okay, then we are going to start together solving polynomial to the power 4. Okay, using the discriminant formula of MOURAD, Sultan, Ezouidi. Okay, I'm just, yes, okay. Now, learners, you can see my screen. Okay, so let's focus first of all on okay, on this polynomial to the power 4. Okay, I'll just start reading this polynomial to the power 4. Okay, the polynomial to the power 4 learns is as the following. Is x to the power 4 minus 20x raised to the power 3 plus 2,997 x squared minus 19,970x plus learners 997,002.5 equal what? Learners equal 0. So our target learners is that finding out all the roots of this polynomial to the power 4. You can see that this is a polynomial to the power 4 pq. Okay, where 4, let's say, denotes or means the degree of this polynomial, and k, let's say, denotes the order and not its order of multiplicity. Therefore, learners, you can see in order to find out all the zero or all the roots of this polynomial, learners, you should first of all find out the SRPQ dash, means let's say the fourth values, okay, relating to the LRPQ, okay, where R, learns, here goes through the set of numbers, okay, minus 1, 0, 1, 2, and 3. So in other words, learners, you have to find the polynomial form of 4PQ. This is a new polynomial you will get after, let's say, using the discriminant formula of MOURAD, Sultan, Ezouidi. Okay, I'll just reduce the size so that the page will be clear for you. Yeah, like that. Okay, learners, now we start. We told that we are going to use for k equal 0, meaning that you are going to substitute k equals 0 in the formula of MOURAD, Sultan, Ezouidi in order to find the value of sk minus 1 of order r, which is equal, in fact, to the sum r from 0 to k, combination n minus r, choose k minus r, n raised to the power r times, between parentheses, negative L0 for the cube raised to the power k minus r, LR minus 1 over the cube. Okay, this formula, learners, I will just, first of all, I will just start like that. This is, learners, is the coefficient of our polynomial to the power 4. Okay, now change this, Mr. MOURAD, if it is better, if it is possible, of course. Okay, brown. Now brown is not clear. I'll choose this one. Not clear, Mr. MOURAD. So I'll choose a blue color. It's better. Okay. Therefore, learners, the formula of MOURAD, Sultan, Ezouidi, it's called a discriminant. Okay, discriminant. Use the discriminant, Mr. MOURAD, discriminant formula of MOURAD, Sultan, Ezouidi, which is that, learners. Okay, it's very important formula. Okay, because this formula is obtained after 14 years of work. Okay, I'll choose this color. Okay, this is the formula, learners. Okay, I'll just now appear there. I want to find the value of s minus 1. Okay, I'll just insert an row first. Okay, okay. Mm-hmm. Yes, this one. So this one, learns, it's called the discriminant formula of MOURAD, Sultan, Ezouidi. Okay, this one, it's called the discriminant formula of MOURAD, Sultan, Ezouidi. Okay, therefore, we start, learners, we told that for k equal 0, okay, we'll obtain the following. Okay, we'll obtain the value of what? The value of s minus 1 of order q. Okay, by conventional learners, s minus 1 of order r is equal to 1. Just replace k with 0 and r with 0. We'll obtain a combination n minus r. Choose r and raise to the power r times between parentheses L0 of order q raised to the power negative r. Lr minus 1 of order q equal s minus 1 of order r, which is by conventional learners is equal to 1. Okay, so now we uh, we try to find the value of the value of s0. Okay, we just substitute k equal 1 in the formula, in the discriminant formula of Mourad, Sultan, Ezouidi. Okay, I'll just follow like that. I will tell that put k equal learns equal 1, we'll get this formula. Okay, we'll get what exactly? We'll get learners the following: the s0 of order r. Why s0? Because k minus 1, k is 1, so therefore 1 minus 1 is 0. Okay, raised to the power r. So I'll just write it as 0 of order r equal the sum from 0 to 1, combination n minus r, 1 minus r, of course. Okay, n raised to the power r between parentheses negative L0 for the q raised to the power 1 minus r times Lr minus 1 over the q. Learn this one, okay, it will be combination and choose 1 when r equals 0, n raised to the power 0, between parentheses negative L0 for the q raised to the power 1 times L minus 1 for the q. This one, learns, is 1, okay? And when r equal 1, learns, it will be combination n minus 1, choose 0. This one, learns, is 1. N raised to the power 1 between parentheses negative L0 for the q raised to the power 0, which is 1, learns, times L0 for the q. This one, you can see that, in fact, is equal to 0. Okay, this one is equal to 0, learners, simply because there is a common factor. Okay, I will put it outside the brackets, then I'm going to calculate. Okay, therefore I'll just write this, imply that, learners, imply that exactly. Okay, that s0 of order r equal minus combination, let's say n choose 1, L0 for the q times L minus 1 over the q plus n L0 for the q. Okay, therefore this one, learners, you can see this is a common factor. Okay, I'll put outside the parentheses. It will be S0 for the r equal negative, okay, combination n choose 1 plus n all times what, learners, times L0 for the q. This one is 0. Therefore, for, let's say, the value of 0 of order r for any polynomial to the power n is 0. Okay, this is the formula. Now, يقين 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 يقين. Okay, therefore, learners are just يقين. No, I need this one. Okay, I'll just change the color of this. I want it blue or yellow. يقين. Okay, it's green. Okay, no problem. Therefore, just I will substitute now, learners. Okay, I will get a 0 for the I equal negative 4 times 20 plus times 1 plus 4 times 20, which is equal to negative 80 plus 80, which is equal to 0. Okay. Okay. Yeah, Juri. Juri. Yaqeen. Yaqeen. Okay. Just a moment. I will switch the AC on. Yeah, Yaqeen. 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 Okay. I will go by myself. Okay, just wait for me. I will come. Okay. I will switch the AC on. Okay, then I will come. Okay. Okay. We told that learners that we went to. Okay, we continue. Therefore, now we found the value of S0. We should find the value of S1. Okay. To find the value of S1, learners, you should put K equals 0 in the discriminant formula of MOURAD, Sultan, Ezouidi, so that find out the value of it. Okay. Therefore, we'll use the discriminant formula of MOURAD, Sultan, Ezouidi. We will obtain that S1 of the R equal the sum from 0 to 2 combination enter. Okay, this one, learners, if you want to simplify more, you will get the following. Okay, you will get the S1, in fact, equal combination and choose 2. Okay, 0 for the q raised to the power 2 times L minus 1 over the q. This one, by convention, learners, is 1. Okay, because I, let's say, divide, let's say, my original polynomial by the first coefficient of the x term that is to the power n. Okay, that's why here is 1 plus n combination n minus 1 choose 1 between parentheses negative 0 for the q raised to the power 1 0 for the q plus n squared l of 1. Okay, therefore, learners, if you want to continue, you will obtain that S1 in fact equal L0 for the Q, okay, squared, simply because the C's and this one and that, it's called the common factor. And the negative sign, it will be in front of n minus 1, choose 1, okay? It will be L0 for the Q raised to the power 2 times a combination n choose 2 minus learners n cn minus 1, okay, plus n squared L1 of O D Q. This one, okay, you will obtain learners, yes, you will obtain learners that S1 in fact equal minus combination n choose 2 L0 for the q squared plus n squared L1 over the q. This one, it's called the discriminant formula of MOURAD, Sultan, Ezouidi when k equal to, okay. This is, it's let's say, general formula, okay, for any polynomial to the power n. If you want to solve any problem, you should pass through this process or these procedures. Okay. Now, learners, I will just substitute. Okay, I'll just substitute this in the formula. Okay, I will obtain. Just I will give its own color. Okay, green, blue. Okay, no problem. Okay. Now, learners, I will just now use the calculator. Every one of you can use his own or her own calculator, okay, to figure out the value of the discriminant formula of MOURAD, Sultan, Ezouidi when k equal to. Okay, I'm looking for a calculator. Okay, So this is new methods, in fact. Okay, and you can use these methods to calculate, to find out all the roots of any polynomial to the power n. Okay, and you should be familiar with this formula because it's very important. Okay, therefore, learners, I will just continue. I will wait the calculator, yes, the scientific calculator to be open. Therefore, we told negative 4 combination 4 choose 2 means negative 6. Negative 6, Mr. Murad. Okay. Times L0 for the Q is 20, 20 squared. Okay. Plus learners what? Plus 16 means 4 squared. I will use the formula as it is. So to let the chance to the learners to understand, okay, times what? Times 2000, okay, 2097. This one, learners, should be equal to 31,000, okay, 31,150. Therefore, we just calculate this one. I'm going to proceed to obtain, let's say, to obtain S2 when K equals 0, when K equals 3 learners, means that you should put or substitute K equals 3 to find S2. Okay. Now I'm going to find the value of S2. We told that S1 is 0. Okay. We should find the value of k of learners what of s of s2 means that we already put k equal 3. Okay, to find the value of let's say the value of s2. Therefore s2, it's uh, it's obtained when k equals 3 in the discriminant formula of MOURAD, Sultan, Ezouidi. This S2 is equal the sum from 0 to 3, combination n minus r, choose 3 minus r, n raised to the power r, between parentheses, learners, negative L0 for the q raised to the power 3 minus r, L, r minus 1 over the q. This one, if you replace learners r with 0, then 1, then 2, then 3, you will obtain the following terms. Okay, you will obtain combination n choose 3. Okay, between parentheses, negative L0 for the q raised to the power 3 times L minus 1 over the q. Okay, because r is 0, 0 minus 1 is minus 1. Plus, when r equal 1, it will be n raised to the power 1. Combination n minus 1 choose 2. Between parentheses, negative L0 for the q raised to the power 3 minus 1 is 2. Times, let's say when r equal 1, it will be 1 minus 1 is 0. It will be L0 for the q. Okay, plus. Now, learners, when n equal 2, it will be a combination n minus 2, okay. Then 3 minus 2 is 1, okay. N raised to the power 2 because r is 2 times negative L0 for the q raised to the power 1 plus times, of course, L1 for the q. When now learners r is 3, it will be 3 minus 3 gives 0 here. Combination n minus 3 to 0 is 1 in fact. And cubed, okay, times between parentheses negative L0 for the q raised to the power 0. Okay, 0 for the q is different to 0, so this one is 1 times L2 of all the q. To simplify this, you can notice that you can see that the L0 for the q raised to the power 3 and this one L0 for the q raised to the power 2 times L0 for the q, in fact this one, and that it's called the common factor. I will put my common factor, let's say, outside the brackets. Okay, so it will be negative. Here the last, it will be negative. Okay, after simplification, learners will obtain that negative combination n choose 3 at 0 for the q raised to the power 3 plus n minus 1 choose 2 times L0 for the q raised to the power 2 times L0 for the q. This one and this, learners, called, let's say, common factor. Okay, minus combination n minus 2 choose 1 n squared L0 for the q choose 1, okay, raised to the power 1 L1 over the q plus n cubed L2 over the q. Now, if you want to simplify this formula, the discrete formula of MOURAD, Sultan, Ezouidi, when k equals 3, you can, let's say, write it as the following. Okay, you will write that. Okay, I'll just go down. Okay, it will be, learners, after we told simplification, we told that it will be L0 for the Q raised to the power 3 between parentheses minus combination n choose 3, it's written here, plus n combination n minus 1 choose 2, it's written here. Then minus what learned the rest, no change, okay. We did not change this one. It will be, I wrote it as it is. I wrote them as they are, okay. It will be negative combination n minus 2 choose 1 and squared L0 for the cube choose 1 L1 of the cube plus n cubed L2 of the cube, okay. Therefore, learners, this one can be written as, okay, we told this is, okay, now change for this, and we move to this one. This one, learners, it's the last, the simplest form, okay, of my discriminant formula, okay. So it will be S2 equal, in fact, 2 combination and choose 3, okay. Positive 2, I mean, because 2 is even number. That's why there is no negative sign here. It will be 2 combination n choose 3 and 0 for the q raised to the power 3 minus n minus 2 choose 1 times n squared times L0 for the q times L1 of odd cube plus n cubed L2. Okay, therefore, now just I will calculate this one. I will use my calculator. Okay, so I hope that everyone has his or has her own calculator to find out the value of K of S of S2. Okay, now this is S2, learners. Okay, I'll just calculate now and find the value of that. Okay, I will use my calculator. This is my calculator, learners. I'll put up so that it will be clear for you. Okay, now, learners, we told that 2 times 4, because when n equal 4, okay, it will be combination 2 choose 1, 4 choose 3, which is why 4, because the highest power is 4, okay, times L0 for the q raised to the power 3, L0 for the q is 20, then minus combination 2 choose 1, 4 raised to the power 2, then 20 to the power 1, times L1 is 2097, plus n cubed means 4 cubed, times L2 is 19,970. I will use this last one after substituting the value of L0, L1, and the value of n. I will use my calculator. It will be 2 times 4 is 8, times learners 20 cubed, okay, cubed, Mr. Murad, okay, minus 2 times 4 squared, minus 2 times 4 squared means 16, okay, times L0 for the q is 20, times learns L1 for the q is 2097, then plus 4 cubed is 64, times 19,970. Then I will make the equal sign. It will be equal to 0. Therefore, the value of S2 equal to 0. Okay, I will continue, learners. I'll just tell you something. Okay, I'll tell you something here. Okay, I'll just say this one. I will wait. Okay, live. This is live. I will wait. Okay, live. This is live. Okay, we continue, learners. I will use this. Okay, live. I will close this. I will come here. I will show you something. Okay, this is the Addition University. I will show you my books. Okay, let's say a book that consists of all the theory of MOURAD, Sultan, Ezouidi. Okay, I'll just make connection. Then I will come to this new page. I will get to my projects. Okay, all of these are my books. Okay, so I will go to the methods of resolution of polynomial to the power n. I will, let's say, upload this one, and immediately I will go to the formula that I use it. Okay, this is the book. Those who are interested, let's say, in learn solving polynomial to the power n. Okay, here it's a wonderful book that contains so many methods, okay, with their own proof. Okay, means when I'm starting working on this topic, okay, this is let's say the teacher Mourad Sultan is really the author. Okay, this is the ISBN, and this is how to say it, methods of resolution, okay, polynomial to the power n. This one is written in French, okay. So let's move there now to the formula that I use it, okay. It's my book. I prepared more than one book, in fact, okay. I will make it bigger if it is possible. I will see where to zoom this for you, or I'll make plus. It's better, yes, like that, okay. Now I will go here, learners, okay. I'll come here. So therefore, I will show you the formula of I will reduce. Yes, okay. For example, this is learned is a theorem. Okay, it's a theorem, and this it's its own proof. Okay, so let's move to the discriminant formula of Mourad Sultan Ezouidi. Okay, this of course my book for author use only. Okay, and I got my ISBN. So therefore, this is it's now available for anybody who can, let's say, who can work, okay, and who wants, let's say, to find solution for any polynomial. Yes, these are my methods for solving polynomials to the power n. Okay, how it comes here, learners. Just there is a theorem. This theorem, let's say, uh, yes. To prove, to make, let's say, to demonstrate this theorem, I needed more than 40 pages to do this one. Okay, okay, we'll continue, learners. I'll just show you the formula that I'm using now. Okay, this formula, learners, that you are going to see now is how can you find out the powers of roots raised to the power n whatsoever. Okay, it's a good method, it's a good theorem. Okay, you can apply and you will get that. In fact, it's very delicious and awesome formula. Okay, we continue. I'm looking for the discriminant formula. I wish that I will obtain as soon as possible. Okay, I will go back. I'll go down just a moment, like that. Okay. Okay. Okay, just a moment. I'll check this one. Not this. Okay. Yes, this formula. You see this one, learners? As k minus 1 over the r is equal to r equals 0 k combination n minus r, k minus r, n raised to the power r minus at 0 for the q, k minus 1. Of course, if you are going to use this formula, just substitution here, okay, with k equal p, let's say, p minus 1 minus k, okay. So we'll obtain this formula. Also, this one and that is the same, okay. So I'll just now, I will told that we use this one, okay. I will now go back to this one, okay, to continue, learners. Okay, now we continue. We told that we use it, in fact, this formula of Mourad Sultan Ezouidi. We obtain the value of S2 is equal to 0. Therefore, learners, here we should, let's say, find now the لا إله إلا الله محمد رسول الله, find the value of S3. So therefore, we should put what, learners? Put K equal 4. K to obtain, let's say, to obtain what? To obtain S4. Now, learners, S3 is 4 minus 1. Okay, is 4 minus 1, which is equal to, learners, equal the sum from 0 to 4, combination n minus r, 4 minus r, n raised to the power r, between parentheses, negative 0 for the q raised to the power 4 minus r, l r minus 1 over the cube. This one, learns, when r equals 0, you will obtain n combination n choose 4, l0 for the q raised to the power 4. When r equal 1, you will get minus n combination n minus 1 choose 3, L0 for the q raised to the power 3 times L0 for the q. This one, in fact, is L0 for the q raised to the power 4 as this exactly, which is common factor. Plus, when r equal 2, learners, you will get combination n minus 2. 4 minus 2 is 2. N raised to the power 2, L0 for the q raised to the power 2 times L1 over the q minus combination n minus 3, choose 1, n cubed, L0 for the q raised to the power 1 times L2 for the q plus n raised to the power 4, L3 for the q. Okay, so therefore, learners, we just calculate or find the simplest formula of discriminant formula of MOURAD Sultan Ezouidi will obtain as the following: S3 equals 0 for the q raised to the power 4, because this is common factor. Then times what? 4 n choose 4, n choose 4 minus n times n minus 1 choose 3 minus n combination n minus 1 choose 3 plus the same, no change. Okay. Therefore, learners, I will just see that the S3 equal negative s negative 3, okay, times what, learners? Times combination n choose 4, L0 for the q choose 4, plus to the power 4, sorry, plus combination n minus 2 choose 2, n squared, L0 for the q squared, L1 of the q, minus combination n minus 3 choose 1, n cubed, L0 for the q choose 1, times L2 for the q, plus n raised to the power 4 times L3 for the q. Okay, this is the last formula, this is the last discriminant formula, the last simplified discriminant formula of MOURAD Sultan Ezouidi when k equals 4. Now, learners, we obtain the value of L1, L minus 1, sorry. This is L minus 1, Mr. MOURAD. I will just appear this one is L minus 1. Yes, this is L minus 1 is 1. And L0 for the Q is 20. L1 is 2097. L2 it's 19970. And L3 is 49,300. Therefore, I will use my calculator. I will obtain like that. Just I will check if okay, yes, okay, okay. So therefore, I will use my calculator. I will write negative 3 times 20. Okay, negative learns what? Negative 3 times 20 raised to the power 4. Okay, plus 4 squared is 16 plus 16 times 20 squared is 400 times what, learners? Times 2097. Then minus 4 cubed is 64 times 20, learners, only, times 19,970 times 19,970. Okay, then plus, learners, 4 raised to the power 4 is 256 times what? Times 997,002. Okay, 0.5. This one will give us exactly, okay, will give us, learners, okay, we'll check this one. Okay, okay, I'll check the value of this first, of this one. Okay, we'll make a reduce here. I'll check this one. Okay, okay, I'll come here. I'll check my original polynomial. We told that, yes, this is 9970. Okay, I'll check my original polynomial. Yes, 99. Okay, 997. Okay, so we'll continue learners. We'll obtain the following. Yes, this is 19. Okay, this one learns, we told that. This one is 19. 90. Okay, no, sorry, is 997,002.5. Okay, then I will erase this. Okay, therefore, because this one is the same as that, now I'll go back to calculate again. I will suppose this is 200. Okay, 38 million 291,840. I will make copy, then I will keep it here to check the rest. Okay, I will make a copy here. Now I will repeat learns. I will use the calculator. So we told that -3 times what times times 4 choose 4 is what? So -3 times 20 raised to the power 4. Okay, then plus 4 squared plus 4 squared times what? Times 20 squared times 20 squared times learners 2000 times 2097 minus 4 cubed 4 raised to the power 3 times what? Times 20 times learners 19,970 19,970 plus what? Plus learners 4 raised to the power 4. Okay, means 256. Times learners 997,002.5. This one should be equal to, okay, yes, equal to 242,611, 840. So this is, I'll just erase this one. Okay, the last one that we did it. Okay, now I will close this one. Okay, I will close this one. I calculate already. So therefore, we continue. Now we obtained a new polynomial. Okay, this new polynomial is obtained from the discriminant formula of MOURAD, Sultan, Ezouidi for any, let's say, polynomial to the power n. Okay, now I'll just calculate this. We told that S0 is 0, S minus 1 is different to 1. Okay, I will use this one. Blue. It's not clear. Okay, to clarify this, brown, green, not clear. Change the color. Okay, it's better like that. Now learns, we told that S1 is 0, S2 this is of course S2 is 0. Okay, or S0 is 0, but S2, this is S2 is written صح. I will take it here. I will cut this. Okay, cut this, Mr. Murad. Okay, now I will write here S0 is 0 and what, Mr. Murad? And S okay, S2 is 0, but S1 is equal to, okay, S1 is equal to 31,150 and S3 is equal to 242,611,840. Now I will write my new polynomial like that: x4 minus S0 for the x3 plus S1 for the x second minus S2 for the x plus S3 for the equals 0. Therefore, We can note that S0 and S1 is 0. I will just write the value of S2 is 0, and S0 and S2 are 0, S0 and S2 are 0. Therefore, we'll just write polynomial P of X equal, okay, like that. I will use this, is learners, is, okay. I'll just write P of X equal X4 plus S1 of R the R, X squared, plus 31,152 X squared, plus S3 learners, S3 is that 2,042,611,840 equal what? Equal 0. Therefore, you can use the formula of discriminant formula of Murad Sultan Ezouidi when n equal 2, will obtain that learners, okay, will obtain that S1 of order R dash equal negative combination n choose 2 S1 of order R squared plus n squared times S3 of order R. Therefore, learn S1 of order R equal negative. This is the formula because 2 choose 2 is 1 plus, okay, means that you are going to pose or to put x squared equal u, for example, or u squared equal x, okay. Okay, therefore we'll obtain S1 R dash equal, I will use my calculator, okay. I will make times what? Times 4, times this one times 4, minus 31, 152 squared, okay, 52 squared. This one learns equal what exactly? I'll check again. We have this one, okay. I will put up. So we have negative 31, 152 squared, okay, this one plus 4 times what learners times 2042 million 611,840. This one should be equal to 256, equal 256, okay. Therefore, I'll just come here, I will make bigger than usual. We told this one equal what learners? Equal 256. This calculation, this one, if you want, I will repeat again. Okay, so that every learner, every student or professor will be confident of my own discriminant formula. Okay, we told that negative 31152 squared, okay, plus 4 times learns what? 2042, 611, 840. This one should be equal to 256. This one. Therefore, the negative, the negative, let's say S1 of the dash equal what? Equal negative 256. Okay, which is negative in fact. Okay, now I will continue. I will close this one. Okay, I will close this one, learners. Okay, I will close again like that. Okay, now I will go back. Okay, I will make smaller so that you can see. Yes, okay, 256. Therefore, negative S1 for the dash equal negative 256. Okay, now learners, I will use this one. Okay, how can I use it? This one I make bigger. Okay, I will make like that. This is also like that. Okay, now I will close this one. I will come down to figure out the value of my my roots. Okay, control home, blue, yellow. Okay, yellow, it's good. Okay, now learns. So that therefore x squared equal negative s1 of order r plus root of negative s1 of order r dash divided by 2, or x squared equal negative s1 of order r minus root of negative s1 of order r dash all divided by 2. Let's start with the positive side. So it will be negative 31,152 plus root of negative 256 divided by 2. This one will give you immediately negative 31,152 plus 60 ik minus 1 is I squared. You can also put exponential, okay, it will be I pi over 2, exponential I pi over 2, divided by 2. Therefore, this one, negative 31,152 divided by 2 gives you negative 15,576, plus 16I over 2 is plus 8I. Therefore, xk, this is x squared, okay? So, in order to find xk, xk should be equal to, of course, k belongs to 0 and 1, equal root of x squared exponential ik pi. This one will give us exactly xk equal negative root of negative 15,576 plus 8I times exponential ik pi. This is the roots of my new polynomial that is obtained from the discriminant formula. Now, in order to find the roots of my original polynomial, original polynomial to the power 4 is alpha k belongs to 0, 1, which is equal L0 for the cube plus xk from 0 to 1 over 4, of course, because polynomial to the power 4, that's why we divide it by 4, equal 20 plus root of negative 15,576 plus 8I exponential ik pi over 4. These are the two roots of my polynomial ik. So in order to continue, I should find out also the two other roots. I will just continue. I will tell that x squared is negative s1 over the r minus root of negative s1 over the r dash over 2. This one will give you, after simplification learns, it will be negative 31,150 over 2 minus 16I over 2. So after simplifying both this complex number by 2, we'll obtain another complex number. Okay, it will be negative 15,576 minus 8I. Therefore, xk, k from 0 to 1, is the root of x squared, which is root of negative s1 over the r minus root of negative s1 over the r dash over 2. This one, okay? Exponential ik pi, simply because this is x squared. I can write here exponential 2ik pi. Then when let's say taking the root from both sides, we'll obtain here divide by 2, 2k pi divided by 2, divide by 2 gives you ik pi. Therefore, this one will be equal to negative, to equal root of negative 15,576 minus 8I exponential ik pi. Therefore, alpha k belongs to 0, 1 or 2, 3 whatsoever. It's L0 for the cube plus xk 0, 1 over 4. It will be 20 plus negative root of negative 15,576 minus 8I exponential ik pi over 4. You can see that the roots of my polynomial are let's say complex number ik. Therefore, we thought that we use the discriminant formula of MOURAD, Sultan, Ezouidi, which is that, okay? I'll just read the theorem, okay? This one is written in French. I'll just tell soit Pn of x égale la somme de 0 à n moins 1 to la puissance k, lk minus 1 okay, d'ordre q kilon times x raised to the power n minus k, polynomial to the power, let's say, 4, okay, where k, let's say, denotes its order and n let's say its own degree. Okay, for k equal 1, on we have for any k belongs to 0 and n, p belongs to 0 and n, we'll obtain the sum from 0 to p plus 1 minus k, combination n minus r, p plus 1 minus k minus r, n raised to the power r, between parentheses, minus L0 for the q raised to the power p plus 1 minus k minus r, L r minus 1 about the q equal sp minus k raised to the power of order r. Or thus formula, also it's called the discriminant formula of MOURAD. It's really both of them. But now we continue, learners. We told that here it's an opportunity for you learners to get the point how can we solve polynomial to the power 4ak. Now learners, it's clear for you, ak, that's okay, that we already solved with this polynomial to the power 4, okay, which is complex, which where let's say the roots are complex number using the discriminant formula of MOURAD, Sultan, Ezouidi. Therefore, I'll just close this parenthesis, okay. And inshallah soon I will also explain more methods, okay, and I wish that everyone now get the point. Okay, get the point. How can he solve polynomial to the power n using the discriminant formula of MOURAD, Sultan, Ezouidi? Okay, I'll just close this. Okay, yes, 94. Okay, now I will close this one, learners. Okay, I will close save successfully. Okay. I will go to my own book. Okay, this one, learners, there are, you see, in fact, so many theorem here were had been written. Okay, this is of course the discriminant formula of MOURAD, Sultan, Ezouidi. Okay, and we demonstrate it. Okay, and this work had been done after, let's say, 14 years of work. Okay, and also yes, this is S3. Okay, that we told. This is S2. This is when k equal 3 we'll obtain S2. Okay, and so on. So this is a 3 that we just calculated. Okay, the last one that obtained 242,611,840. Okay, this is S4 for polynomial to the power 5. And if you want to continue, we'll just put k equal n and so on. Okay. Therefore, learners, we just give you a slight idea about my own formula. Okay. Yes, this is my own formula. My own formula that helps you to figure out the value of sk minus 1 over the r. Okay. We just will just show you something here. The formula that is written in the name of MOURAD, Sultan, Ezouidi, it's an important formula. It's an important formula, but I didn't find time, in fact, to use this one, okay, to prepare a book for it. I already, let's say, prepared so many books, learners, okay. This is also the same formula that we use it, okay, but differently with other indexes, okay. So we'll just continue. Okay, I want the formula that is written under my name, learners. It's very important. Okay, and if you want to be good at polynomial, you should be familiar to its own coefficient and how can you find the the let's say powers of 0 of polynomial. Okay, don't use the classic method or okay, here are so many methods, in fact, okay, which are very important and handsome. Okay, I'll show you just the formula. of Mourad Sultan Ezouidi. This book is written in French. I already, let's say, sent the new manuscript for European edition. Okay, but they didn't accept the English version. They accept only French version. I don't know why they are behaving like that. Okay, this is of course pulling to the power 6. Okay, we did it before in the book, and I prepared so many books. Even I prepared a book that contains method for solving polynomial to the power 30, and polynomial to the power 18. Okay, 12, 16, 11, 13, and so on. Okay, so I'll just show you something here. I also use a logarithm. Okay, this is on 2010, I thought. Yes, 2010. Okay, I started writing my books. Okay, okay, we continue showing something which is very important. Okay, Mr. Murad. Yes, this one we did. Okay. Mm-hmm. We hope so that we can reach this formula. I will just go down. Okay, where is it? Where is it? Where is it? Okay, thought we reached it. Yes, this one learns. It's very important formula. So let's Pn of x equal to the sum from 0 to n minus 1 raised to the power k, lk minus 1 over the qx n minus k, or polynomial to the power 4. Okay, so Sultan Hania Ezouidi Mourad, this is my own formula, equal the sum from 0 to p, combination p plus 1 choose k, between parentheses, L0 of all the q raised to the power p plus 1 minus k, times, between parentheses, negative 1 times raised to the power p plus 1 minus k, n raised to the power k, L0 of all the qk, okay, not k raised to the power r, no, qk, okay, plus 0 of all the q. Then I should close the parentheses 2 times, this one equal to 0, okay? And really, it's, let's say, a good formula, this one, okay? I already, let's say, make another formula that derives from the first, okay? And this is the proof of it, okay? Okay, what else? So, I wish that everything is okay for you. It's clear for you, learners. You can choose this book. It's very important. Okay, it's in Amazon. You can buy it. Okay, and you can benefit from it to at least to present 1 hour for you to understand the methods. Okay, thank you, and bye. Before going back, yes, it is work. Okay, I'm live. Okay, I want you to support me also. Okay, learners and teachers and professors. Okay, here I will change this one. I'll change after learners. Okay, therefore I also pronoun to the power 18, this one. You see pronoun to the power 18, solving pronoun to the power 18, and this is the book. Okay, and also 12. Okay, 12, this one 12. Okay, so this is 8 to the power, polynomial raised to the power 8. So in fact, it's a booklet of research of Mourad Sultan Ezouidi. Okay, thank you for listening, and see you inshallah next time. Okay, I'll just end